This lesson is about exponential decay. Exponential decay, this should say decay, occurs when a quantity exponentially decreases over time. So you notice the formula's difference here is 1 minus r instead of 1 plus r, which is what it was when we were talking about exponential growth. Everything else basically stays the same. A is still the initial value or the initial amount, so the amount you start with. R this time, instead of saying growth rate, will stay decay rate. And T is still, of course, time. Now, some of these are a little bit different than the other ones. They have a different kind of rate that we have to talk about, and the time on some of them are a little bit trickier. Like this first one says, the population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Use an exponential function to find the predicted population for 2008. So in this one, the initial amount is 1,300 because that's the people. That's what the population was to start with. And the decay rate is 0.01 because it's 1%. You got to put that 0 in there to make it 1%. Otherwise, it would be 10% if you just do 0.1. However, it does not give us a specific time. So if it gives you 2 years like this, you cannot just put in 2008 or 2000. Then it's going to figure that decrease over 2000 or 2008 years, which is way, way longer than what we're actually talking about here. So you have to do, okay, how many years happened between 2000 and 2008? And you can put the larger number and subtract the smaller number, and you see that that's 8 years. So our time is actually 8, not the year itself, but how many years have passed. So when we set this up, this time you just got to be sure that when you put in your growth rate or your decay rate, that you are using minus so that your formula knows, oh, I need this to be decreasing because this is a exponential decay. So the subtraction does that for you. And so you're just going to type this into your calculator like we did the last ones, 1,300, and then in parentheses do 1 minus 0.01, and then raise that to the 8th power. And so just like before, this is going to give us like a partial person, which we cannot have. So we're just going to drop the decimal and say that in 8 years, we would have 1,199 people. Okay, I know that you feel like you need to round that up, but we actually can't round up a person. Either you have that person or you don't. Okay, the next one says, a car is initially purchased for $18,000 and depreciates at a rate of 12% per year. Use an exponential function to find the value of the car after 10 years. So initially purchased, that price is $18,000. The rate here is 12%. Now, we haven't had any double-digit rates yet. So when you have a double-digit rate, you do not have to put the 0 in. This one is just 0.12. Because think about this in terms of money. If you had, like on the first one, you've got 0.01, that's 1 cent. If you did just 0.0 or 0.10, that would be 10% or 10 cents. The same is true with the 12. You don't need the 0 in there because if you do that, that means that you're only talking about 1.2% instead of 12%. So don't put the 0 in if you have a 2-digit percentage. And then the time on this one they give us is 10. So we're going to put this into the formula, 18,000, parentheses 1 minus 0.12 to the 10th power. And so then we can type this into our calculator. Make sure you type in enough zeros. Sometimes when we have that many zeros, we make a mistake. And for some reason, I just almost made a mistake there. So make sure you've typed what you meant to type. And so then this is telling us that the car will be worth $5,013.02. So that's 0.017. The 7 rounds the 1 up to 2. And so this is money, so we need that dollar sign. So it will be $5,013.02. The next one is like the last one we did. It is a farmer buys a tractor for $50,000. If the tractor depreciates, and depreciates is just a fancy word for decay, At a rate of 10% per year, use an exponential function to find its value after 7 years. So A is 50,000. Rate is 0.10. So notice the difference in 1% is 0.01, 10% is 0.10, and the time is 7 years. So just to reiterate, depreciate is like the word we use when we're talking about decay in money, or decreasing. That's the depreciate is a word used with money going down, value going down. So that's why they use that word here. So we've got $50,000 times 1 minus 0.10 to the 7th power. So we're going to type that in. Make sure you do 50,000 and not just 5,000. I did that wrong. All right, so 1 minus 0.10 to the 7th power. And so that is 23,914.85. So that you've got, well, here, let me write this down. So the calculator actually gives us this. So because you're talking about money, you just need 2 decimal places. So this 5 rounds this 4 up to 85 cents. So the tractor would be worth $23,914.85. If you need more help, let me know.